Hello, I'm Frank, and I'm here today to talk to you about graphing quadratic equations. So, today's objective is to learn how to graph a quadratic of the form y is equal to ax squared plus bx plus c, where a is not 0. Hopefully by this time you've already discussed solving quadratics for 0. You probably learned how to solve by factoring, completing the square roots, and quadratic formula. Today, however, we're going to learn how to graph them. In graphing, what you've had, such as lines using y equal mx plus b, you were always given a starting point b, and then you had the slope, which is the rise over run, and you graphed it. However, graphing a quadratic is different. It is not a line, and usually you need quite a few points. So we're going to get started on this graphing. All right, so what I have is two examples for you today. Okay, the first example is going to be a parabola, which is the graph of a quadratic, which looks like a U-shaped figure. Now, this graph is going up, so if it's gone up, this leading coefficient in front of the x squared, a, is going to be positive. We're going to graph example 1 looking like that. The second example is a parabola, a graph of a quadratic that's going down, and now there's going to be a maximum point, and this number a is negative. So the number a is going to determine the sign of it, if it's going up, positive, if it's going down, negative. Okay, so the first example we're going to do is one going up. Okay, so that takes us over to the example. The first example is y is equal to x squared minus 4x minus 2. So going back to the quadratic formula, which you've already learned, a is the number in front of the x squared, which is positive 1. That means it's going up. B is the number in front of the x, which is negative 4, and c is the constant term, negative 2. Now, there's a lot of ways to graph a parabola, depending upon where you are in your mathematical study. The first way is to build a table, and that's the way I'm going to show you today. There's other ways, such as completing the square, using intercepts, and also using calculus. And of course, we can graph them on the calculators. Today, we're going to go to what I consider the most basic way, using a table. So the more points we graph, the more accurate it's going to be, of course. But time's going to have constraints, so we're only going to use 5 points. But the most pivotal point is the low point in this case. And that low point has a name. It's called the vertex. Now, we're going to learn how to find the vertex. There's another concept we're going to learn, and that's what's going to be called a line that runs straight down a vertical line through the vertex. And I'm going to denote that with a broken line. Put arrows on it to make sure it's a line. This broken line is called the axis of symmetry. Example, if you were to take a line running through a vertical line running through your nose, right through your face, hopefully that would reflect one side to the other. So whatever's on the right of that line would have to be on the left of that line. This is going to make our job a lot easier by recognizing the axis of symmetry. So our first goal is to find that point vertex. So how do we do it? Okay, as I mentioned, there's a lot of ways to graph it. But the way that we're going to find out by finding the vertex is use the number b and take the opposite of that over 2a. And you may ask, how does this come about? This comes about through the quadratic formula. And that's a concept we will discuss in the derivation later. Today is the first case of this, so we're going to just accept this without further proof. Minus b over 2a is the x coordinate. So let's go ahead and try this example. Okay, we take minus b. If you recall, b is minus 4. So a minus b would be minus a negative 4, and a is 1. So that's what we have. The opposite of a negative 4 is a positive 4, and 4 divided by 2 is 2. So the x value is 2. But of course, we know any point on this plane has not only an x coordinate, but a y coordinate. So we're now going to find the y. So how do we do that? Well, we put 2 right here in the middle, and that's going to be called the vertex. Now, how do we find y? We go to this equation, and every place we see x, we put 2. So we have 2 squared minus 4 times 2 minus 2. Now, in calculating this, this will give us 4 minus 8 minus 2. And a further step will give us minus 4 minus 2, which is negative 6. So our vertex is the ordered pair 2, negative 6. So part A is to ask you what the vertex is. So the vertex is the ordered pair 2, negative 6. So we plot that point. Now, on a Cartesian plane, notice the x and y's are labeled. We go over 2, and we go down 6. And we put a dot. Now, that's the vertex. That's going to be the pivotal turning point. Now, the axis of symmetry. If you recall, the axis of symmetry is a vertical line which runs through that point. So I'm going to draw this axis of symmetry in a broken line. Put arrows on it since it is a line. Now, the equation of a vertical line running through this point is x equal this number 2. Any point on that line has an x value of 2. So if you say that x value of 2, that's your axis of symmetry. So what you'll notice is x equal that number is always your axis of symmetry. Now, what that does is it helps us. Now, since we need 5 points, we need to know points on either side. So let's take a logical number of 1. And we're going to put 1 in there for x. So we got 1 squared minus 4 times 1 minus 2. Now, this is going to give us, if we do the arithmetic together, 1 minus 4, that's negative 3. Negative 3 minus 2 is negative 5. Let's make sure everybody has that. 1 squared is 1, minus 4, 1 minus 4 is negative 3, minus 2 more is negative 5. So we plot that point. We go 1 over and 5 down. But here's the beauty of this. We could go to 3. We could put 3 in there for x and do the same thing. But why do we need to? Because whatever's on this side has to be on that side. That's the purpose of the axis of symmetry. So if we got 5 for negative 1, we're going to get 5 for negative 3. See how nice that is? So we plot that point, 3, negative 5. And we have one more point. Now, choose any one you want. You could choose 4, or you could choose 0. Whatever you get for 0, you get for 4. So which one would you rather put in? 4 for x or 0 for x? I would 0. Here's why. 0 squared is 0. 4 times 0 is 0. So we have nothing. Nothing minus 2 is negative 2. And believe it or not, if you put 4 in there, you will get negative 2. Just to convince you. What's 4 times 4 is 16. 4 times 4 again is 16. 16 minus 16 is 0, minus 2. So there's the points. Now we plot them. We go to 0, negative 2, and we go to 4, negative 2. And we have our 5 points. So that's our table. Now, last, but the most important part is the graphic. It's a U-shaped figure, so let's make it a U-shaped figure. So it goes down through them points. This is the minimum point. It curves. It goes back up, and don't stop it because it goes on forever. And there's your first parabola. So that's the graph of the first quadratic. It's what's called the parabola. This is the vertex. This broken line is the axis of symmetry, and it continues on. We would use this a lot in applications in the business world, where we're asked to find the minimum of something, maybe the minimum waste in a project. So anyway, this is very useful in applications in economics, and it's something that you will see in your further math classes. Now let's flip gears and go to one that's reversed. This one's going to go down, sort of like a McDonald's sign. So let's go to the second example.